Well, myself Uttiyo Muduk from Team Sorcerers. So here is the circuit representation or the simulation done in Tinkercad software. So to explain the basic fundamentals like the Arduino acts as a microcontroller here, the LEDs are just set for the conditions checking, the two DC motors for the movement purpose, the ultrasonic sensor for detecting the obstruction or something, and the motor driver is used for the connections and to drive the DC motors. So to start the simulation, and here by the way, here as there are no LDR sensors present in this software, so I have used photoregisters 1 and 2 left and right as set in the simulation, so for just detecting the brightness and the light sensing mainly. So to start the simulation, here we go, the code part. Here a condition is said that if the obstruction is less than 100 centimeter distance, like as we can see less than 100, the red light will glow. So here it is 51.1, so the red light is glowing. If it moves forward, like that is at least for 100 centimeters there is no obstruction, then there is no such glowing. And the two photoresistors here এখানে ব্রাইটনেস, হ্যাঁ ফার্স্টলি এখানে সিরিয়াল মনিটরে দেখতে পাচ্ছি 54, 54, 125 জাস্ট বেসিক ভ্যালুস। ডিসটেন্স তো সেট করেছি এখানে, সো 128 অ্যাপ্রক্স। তো এখানে ব্রাইটনেসটা 54 লেফট এলডিআর যেটা এটা লেফট যদি ইনক্রিজ করি লাইক 974 ম্যাক্স হচ্ছে, তো স্টার্ট ব্লিঙ্কিং, দ্যাট ইজ দ্য পিক আপ কমেন্ট যেটা জেনারেট হচ্ছে। আমি যদি কোডটা দেখি, সরি হ্যাঁ, তো বোথ গ্রেটার দেন, লাইক দ্য কন্ডিশন হিয়ার ইজ দ্য মেন। সো বোথ ডার্ক মিন্স ফরওয়ার্ড যাচ্ছে। অ্যান্ড সো এখানে ব্রাইটনেসটা যদি ইনক্রিজ করি দেন এটা দেখা যাচ্ছে যে 974 দ্য পিক ব্রাইটনেস। ফটো রেজিস্টার ইউজ করছি কজ বলেছি যে এলডিআর সেন্সার এখন পসিবল, সিমুলেশনের জন্য এটা ভিজিবল অ্যান্ড সবচেয়ে ফিজিবল অলসো। সো ব্রাইটনেসের জন্য এটা দেখতে পাচ্ছি, অ্যান্ড ডিস্টেন্সের এটা অবস্ট্রাকশন ডিটেক্ট করছে, লাইক দ্য মোটর এখানে দেখতে পাচ্ছি আরপিএম জেনারেট হচ্ছে, তো মোটরস আর মুভিং। And to zoom in here also, both the motors are moving, and if obstruction is detected like this is nearer to this both the motor stops. Second, yeah, both of them stops. So this is the simulation diagram that we have created for the robot working principle using the internet of mainly the embedded system, the microcontroller, the sensors, and the motor driver for controlling these two motors. Actually, to visualize more properly and to get a brief idea about what implementation we are doing in this project, mini Python game I have here implemented. The code runs as so. FPS I have set in low so that our eyes can follow number of robots, 3 let's say, or 4 let's say. So to run this, a pygame will enter, like yeah, we can see 3 robots, a task is created, they are like automated here as it's a game, not any create task option shown here. So the robots are automatically detecting it, the pick up and drop. And here to see the status, here it is mentioning idle, picking which robot is doing what, and the coordinates are mentioned here, like from where to where, the exact location I mean. So pick up and drop, this service is here. And automatic generation, just for visualization, this game is a funny kind of a way to view the implementation part of what is doing in the website or in a local hosted website to create a task, how the robots are moving, avoiding obstacles. For that, my teammate Shubh Broto will explain the next part. Thank you.
Here is basically our uh, dashboard for managers, warehouse dashboard. So what happens? Black uh, black blocks in the grid are basically obstructing like cells and other random obstacles. The red dot that glows sometimes and that vanishes. It is some dynamic obstacles, and this is the robots. So how the product manager, like warehouse manager, does make the robot move, pick up from one place to drop off in another. Select current cup point in the grid. Select current drop point. Okay. Now if we create the tasks now, if we click that, it will like search for the nearest robot using KNN, and then using the extra algorithm, it will find the path and move through that. So R3 is the rule. Now here is the interesting part. The small glowing ball in front of the main robot is basically like you can see there. Yeah, see that? it is basically it the robot we show that shown that that robot basically is scans for the for any obstacles in its path in the front grid. Okay, if there's obstacle, it basically changes its path. Why it changes its path here and go back this way? Because there was a dynamic obstacle that just appeared and go away. Okay, now again, if we do it, create tasks. Now see, this robot comes. This robot is in this grid, but it scans this block. Now, if there is obstacle, it changes its course. Okay. Now, again, if we take this to set this create task, this comes. Okay. Now, yeah, this is now when everything is done. When the shift ends and we go home, what we do? We make the robots go in their initial position and go home. So what? End shift and release the robots. So what happens? First, our robots first first robot goes to its main position, and then they make their own path. So basically, this happens. Sometimes this stuff fails like that. I don't know why. Really don't know. Yeah. Now they're ready for next day. Again, do it. Again, they are okay. Again, shift. Yeah, yeah. That's all.